Okay, so see, I will. Uh, yes, I will discuss only problems only. Problems. That's all. Problem discussion only will happen. So we will continue discussing the problems. So let's start the problems. First means as you told this car type of problem. Suppose there is a car and car is going and brakes are applied. Brakes are applied. So as the brakes are applied, the wheel will not be rotating now. Wheels get locked. Wheels wheels get locked. So if wheels get locked means it will just slide over this, and it has initial velocity u, so it will start sliding over the surface just like a block. Just like a block is there, and this block, suppose you throw it with velocity u over this surface, then it will be sliding over. So as this slide, friction will be acting like this way. Friction is going to act like, of course this is kinetic friction only because body is moving. The same thing is happening here on this object, on this car. Kinetic friction is going to act, and this kinetic friction will only stop this because this is causing retardation in that. Right? Okay. So what is the acceleration? Acceleration will be negative, we know, because force is opposite. So minus force by mass. Force is mu times normal. Normal is mg by mass. So retardation is mu. Mass get cancel mu g. Okay. So how much distance it will stop? Stopping distance formula also you know. Finally velocity will become 0. So v equal to v square equal to u square plus 2ax. Also you can apply. So final velocity 0. U square x is negative minus 2. Acceleration is mu g. So x we can calculate u square by 2 mu g. That's what it is. Similarly, if I have to calculate time to stop, so v equal to u plus at. So v0 u is u only, acceleration is minus mu g into t. So time when it will stop is u by mu g. That's what it is. Okay. But note that once it is stop, after that friction will not work, because once a car is stop, after that friction is not going to work. Right? After that friction is not working. No, no, stop means suppose this body is kept here. Rest. Suppose a body is kept rest. Is friction acting? When does friction act? Do you have attended beginning class, na beginning point? Right. There is no tendency now. There is no tendency. So friction is not going to act once car is stop or body stop. After that, no tendency. If somebody tries to move again, then friction will again activate. But right now, once body stop, friction will not work. Okay, that's what it is. This type of questions definitely you can do this. Right. Any blocks over blocks questions will be there. Yes, tell me. Because what is force? Net force formula? Tell me net force formula. Ah, correct. So this direction we are choosing positive. This direction is negative, right? So force is acting negative, so it is minus Fk. That is the only force, horizontal force. Vertical it is balanced only. So horizontal force is minus Fk. Mass into acceleration. So acceleration is minus Fk by mass. Fk is mu times normal. Okay, then next, any doubt in this? Yes, we can solve. You give me this block over block questions are there now in your module. Tell me block over block questions. It will be there in your module. No, no, no. Go to the other modules. Means that other your next exercise. Exercise 3, 4, 5. All these are there. No? There are few questions of blocks over blocks. Uh, tell me any one of the problem. One problem model already we have solved. Give any other type of questions on this. You tell me what are the masses, top mass, how much it is? 10, 20, 30. Then ground has friction or not? Ground. First tell me ground has friction or not? Or ground is smooth? What are the things mentioned? What about coefficient of friction? That's what here zero zero means no friction. Okay, note that when mu is zero means this is a smooth surface. So here mu is how much? Let us take this is mu 1. How much it is? 0.25. This surface mu 2 how much? Okay, okay. This is 0.5, right? Okay, so this surface I am choosing. 100 Newton is applied on which block? Okay, okay. 100 Newton is applied like this, correct? Hmm. It's applied this way or that way, doesn't matter. Okay, so now this question is a typical question which is a confusing or complex type of question, but we'll solve it by the same approach. Same approach. So first of all, if I take entire system, so anyway here it is ground. Here there is no friction at the bottom, right? Bottom we don't have any friction from the ground. Hmm. So what we are going to consider it, we will take this entire system. So total mass of this system will be how much? 10 plus 20 plus 30, 60 kg, right? 60 kg total, total. And total force acting on this system is only 100 Newton. 100 Newton is external force of the system. So we will calculate step 1. What is step 1? Calculate system acceleration. System acceleration is net force, which is 100 divided by 60. That means 10 by 6 or 5 by 3. Correct? Meter per second square. We got access. Now we can calculate. Now step 2. Step 2 is that we need to calculate frictions acting on each surface. Now there are, if you draw free body diagram, now we have to draw on the blocks. At least you show the forces upper. Let us say again, here again the same idea I told. You assume that all the blocks move together. Assume all blocks move together with the same system acceleration. Okay. So assume all these blocks are moving together in the same direction of system acceleration, system acceleration, system acceleration. All the blocks are moving together. So if the upper block is moving that side, anyway here friction we have already we have applied this. So I think you start from looking from the bottom first you draw. Okay, see bottom is moving that way. That means what? Bottom is moving that way means bottom means lowest block. Let's take the lowest block first. So the lowest block, this one, is moving this way. This we'll see afterwards. Lowest block is moving this way with acceleration, system acceleration. So definitely it must be acting, friction must be acting like this way, correct? Friction on this surface must be acting like this way. This is up to. Because if friction act this way, then it cannot move that side, right? And below also there is no horizontal force because it's a smooth surface. So this is no. Opposite of what? First, you do not know opposite of what. You don't know motion. Where is motion? No. See, try to understand. Try to here. See, with respect to this surface, it is moving that side. With respect to which surface? Ground. With respect to ground, it is moving that surface. But ground, there is no friction. Na. If ground will give friction, it will give this way. But ground, there is no friction. And now this friction is given by the upper block, right? So with respect to upper block, you do not know na, which side it is moving because upper block is also moving and this is also moving, right? So, so because see from ground, you look at from ground, which direction it is having acceleration? Tell me, which direction net force must be? That is why. That is why the only force must be friction only, na. There is no other force. That is why friction has to act because this is the net force on this body, right? This friction is going to be net force which is mass into acceleration and its mass is 30 kg and its acceleration is acceleration system. This we can calculate from here, right? So 30 into 5 by 3 we will calculate this as 15 Newton, correct? This will calculate. Also check about the maximum friction at this surface. At this surface max. See now here it's a very interesting. To calculate the friction maximum, you need the normal also, right? Maximum friction. So when you want normal, now you can club this upper two blocks. You can club as a system like this. Upper two blocks is how much? 10 plus 20. This you can take that you can club as 30 and normal acting at this surface is supporting this 30 kg. Okay, that is what it is. So here let us say normal I am talking about. So this normal N2 will be acting here upward and same normal N2 will be acting here. So that N2 must be supporting 30 kg. So N2 must be M into G. So 10 into 30 into G. So let us take G as 10. So this is 300. 300. Now we'll calculate maximum value of this friction F2. So maximum value of this friction is mu time mu they have given for this surface mu is 0.25. So mu into this normal n2 mu2 into n2. So mu is 0.25 and normal is 300. So how much this will come? So 75 Newton come. Now you compare this F2 and F2 max. This F2 is smaller than F2 max, right? Yes. So this F2 is smaller than F2 max, then definitely we can say that it's okay. This F2 is the friction acting here. We can say that. Okay. So because F2 is less than F2 max, so we can say the friction acting here is okay, F2 only, which we have calculated as 50 Newton. This is correct. Okay. Done. Now about and so that means this acceleration of this is same what we have calculated as 5 by 3. So acceleration of this body is 5 by 3. It is moving with 5 by 3 meter per second square. That's what is the axis. So that means the upper two block, if you club that and this block, so upper two block and this block is moving. There is no sliding motion happening here. That is what you have to note. No sliding motion happening here. Yes. What is your question? Because we calculated from using this value only, and then we are saying it is less. It is satisfying the condition, so we have to choose that acceleration only. Then sliding motion will happen. Then if sliding happens, then F2 will be the maximum friction. Maximum is kinetic friction. That kinetic friction you have to use, that is the maximum only, because they have not told here mu k mu s, they have not given, they will not give. Whatever mu is, that is what is mu k or mu s. Okay, so here what you are calculating as maximum, this is the maximum friction is going, because F2 cannot be greater than that. Remember, F2 cannot be, friction cannot be, so sliding is going to happen at this surface. So here maximum friction will be acting, then acceleration will be 75 by 30. 75 by 30 you have to take acceleration, correct? Yes, yes, because if sliding motion happens, then kinetic is acting. Okay, that's what it is. Then also you have to take, it doesn't matter, because if it is equal, then only the same na, force by mass you have to do, whether you do F2 max or F2, both are equal na. So that force divided by mass you will do, right? That will come same acceleration. No, because they are not mentioning here mu s mu k, they are not given na. They have not given, they have just given mu only, so there is no such confusion happening here. Okay, done. So we have done for this, but now we have to do for the upper surface. What is the friction acting here? This place. This place we have to again see. Now here also we need to draw free body diagram, right? Then only we can conclude here. So let us draw free body diagram of the surface. Here we have taken the upper two blocks we have combined, and lower block we have done. Now let us do like this way. So now we have understood that there is no relative motion between the lowest block and second one, right? This one, three blocks are there, right? So this block, there is no relative motion happening. Then what we can do is, let us now combine these two as one block. That means second and third you combine now as a system. Okay. So if you combine the second and third, that will be 20 plus 30, right? Okay. Second and third. Yes, I will tell me. Just now we have calculated now, because if relative motion happens here, then they will be sliding, and if they are sliding, then maximum friction will act. There is no friction there. Why are we calculating that? They have given, no, there is no friction. No, all those accelerations are with respect to ground only. All accelerations are with respect to ground only. So what we have calculated is, we have calculated that these surfaces, there is no relative motion between them. That's what we have calculated just now. Okay, right. But whether here relative motion is happening or not, that is what we need to check. That is what we need to check out. You may study this, or you may combine that also. It doesn't matter. It is your choice. But let us say like this, that these are going together. Or let us do like this. Now let us do in this manner. It will be a different approach. So let us draw free body diagram of individual body. That will be better. Huh? Individual bodies free body diagram. Let us try to draw that. So 10 kg, 20 kg, 30 kg, all that. So just now we have seen that Here friction is acting, and this friction we have just now calculated how much this was. Friction 50 Newton was there. Yeah, that friction is 50 Newton, correct. So the same friction is also acting on this surface because they are interacting. This is F2, F2, right? 50 Newton interaction forces. Okay. Now, now you see this body. Again, you assume that all of them are moving together. Acceleration of the system, right? We have assumed that all of them are moving together with the same acceleration of system. So, if I take like this, and what was the acceleration of system? 5/3, correct? So all of them are, assuming that all of them are moving with same acceleration 5/3 meter per second square. Okay, so now suppose this body has to move this way, then definitely there must be some force that side. This side it is retarding, correct? This side retarding. So there must be friction here like this way. That friction was given from the above surface F1, and that F1 must be given here F1 like this. And note that you have applied a force on the upper block, right? Upper block. How much force was applied? 100 Newton. Now I think this is complete free body diagram. Except normal, we have not normal. We can see if you want normal here, it is the weight of this. If you want normal here, it is the weight above this. Above this. Okay, so note that normal if you want, normal here if you want, normal means weight above this. If you want normal here, weight above this. Okay, that is the idea. So here normal, if you take, let us say this is normal N1, and same normal N1 here, this normal will be weight of 10 kg, right? That will be 10 g, that will be 100 Newton. And this normal which we have already calculated, this normal N2 is weight of all that, right? So that N2 is equal to 30 G, which we have already calculated 300 Newton. No confusion here, right? So now we want to calculate. Okay, so now we have already seen this is 50 Newton. Now we know acceleration. Let us apply Newton's law in this block. Newton's law in this block. So on this block, F1 is acting like this, F2 is acting like this. These are the only two horizontal forces, and it is accelerating that way. So Newton's second law says here that F1 minus F2 will be mass into acceleration, 20 into acceleration of this system. So F1 minus F2 we have already calculated 50. So 20 acceleration here is 5/3. So F1 will be how much? 50 plus 100/3. So that means this is 150 plus 100, 250/3, correct? How much it will come? 3824, 83.33 Newton will come. Okay, that is F1. Now here calculate maximum F1. Calculate maximum F1. What is maximum value of F1? Mu times normal has 0. That means mu1 here. Mu1 into normal N1. So mu1 is 0.5, and normal N1 we have calculated 100. So that is coming also as 50 Newton, correct? Okay. Now see, this friction is larger than this, correct? This friction is larger, so this is sliding here. These accelerations are not same now. Okay, so here friction, of course friction cannot be larger than this. So what friction we should take? We have to take maximum friction. We cannot take, yes. So F1 we need to take as 50 Newton only. Now we can calculate acceleration. So this acceleration, let us say this is A1, this is A2, this is A3. A3 we have already calculated 5/3, right? A2 and A1 we have to calculate. So now we got F1 acting as 50 Newton, 50 Newton. Now you calculate this upper one A1. So 100 minus 50, that is net force, right? So A1 you calculate easily. 100 minus 50 total force divided by mass is 10. That means 50/10 is 5 meter per second square. That's the acceleration of paper block. Similarly, acceleration of the second block will be this F1 minus F2. This is coming 0, right? F1 minus F2 is coming 0, so this is not moving. So F1 minus F2. So 50 minus 50 divided by mass, which is 20. So that has come as 0 only, 0 meter per second square. Is this possible? Think about it. Does it look possible? No, no, the object which you are studying, that object you have to take. We are not taking system here. So when you one minute, somewhere I think some wrong is there. Once you check the answer, I think it is not correct. Some mistake is there because not possible. Check once answer. All middle one now. No, no, all the acceleration we are calculating with respect to ground only. It's not relative to objects. We are saying with respect to ground. Okay. So where the mistake has happened and where is the error in the approach? Somewhere mistake has happened in the approach only. Approach we need to correct it. Okay. So approach we need to correct it. Should we go from bottom to this way? That may be better, I think. Like how did we started analyzing acceleration system we have calculated, then we have we have to go in the same manner. Okay, let us go in the same manner. Instead of separately doing it, we have to first assume it that they are going with that same way. I think here we have made some mistake has happened here. Mistake. Okay, let us correct it. First calculation for this block we have done correct now. That is correct only. But second approach we have made mistake because we have broken it into two. Okay. So instead of breaking into two, we need to combine this two, right? This block which we are taking, the upper block and this middle block. Let us combine this as a system now. So that was 10 kg and this was 20 kg, and they are going with the acceleration of this system. Acceleration of this system, which was 5 by 3, 5 by 3. Okay. Now they are going together means, and you have applied a force here as 100 Newton. Correct? 100 Newton you have applied. Now already we have seen that here friction is acting like this way on this F2. This F2 was 50 Newton. We have already calculated that. Correct? F2 we have already calculated that. Calculation we have not made mistakes now. Just check calculation, did we make mistake? Previously this friction F2 which we have calculated, that was smaller. So, okay, maximum friction was F1 maximum was 50, but F2 maximum was different, right? F2 maximum was different, which we have calculated. F2 maximum was different. Okay, I think calculation not a problem. Okay, now I assume like approach, we have to find out a better approach so that we can get the correct answer. So first we have taken system and we found that there was no relative motion between this above two block and the lower block. So we have found that what friction is acting, we have calculated that, we have got here. Now assuming that they are moving together, so definitely here friction F1 must be acting, here friction F1 must be acting. Now let us say that they are going together. Okay, they are going together. Now let us try to calculate F1. Either you use this one or you use that one. Okay, Either you use this one or you Newton's law apply. Let us say I apply the top one. So 100 minus F1, this is net force, is mass into acceleration of this system. Let us calculate this. 10 into 5 by 3 is 100 minus F1. So 100 minus F1 becomes 50 by 3. So F1 becomes 100 minus 50 by 3. So 300 minus 50, 250 by 3. This F1 is coming how much? Same, 53.33. And what is the maximum value of F1? Mu 1 times normal and 1. So 0.5 into 100. So this was 50 Newton only. Definitely sliding is happening here. At this surface, sliding is happening. So if this surface sliding is happening, we need to consider friction as that maximum friction only. We have to consider 50 Newton only, correct? But then the problem is that this block doesn't seem to be moved because here forces are getting balanced, right? Very good. What are the answers they have given? Expressions. What are the expressions they have given? No, no, three blocks are there. Now, what is the acceleration of the first block? 10 kg. What are they asking in the question? Acceleration of middle block. How much is answer? What what is the answer they have given? This is with respect to ground only, right? So that means second acceleration 2 should come 1. Where the mistake has happened, there must be a fundamental mistake. There must be a fundamental mistake. We need to see, this is where we need to think of, because see, we have developed an approach for two block system only, right? Three block system, we are just trying it. So how to make this three block system a two block system? We have to think, how can we effectively make this three block as a two block? Think about it. You take, it doesn't matter, but see the approach. Remember, in that two block system, force was acting on one block and other block force was not acting. Means friction was acting, but we have not applied any force, right? Okay. So I think that clue is there in that approach. There is a clue there. We need to find out. I think the clue is like this way. The clue is like this way. How to apply this in three block system? Suppose I have to take like this three blocks here. This is 10 kg, 20 kg, 30 kg, and we have applied force here, right? Here we have applied force. So now look at this. If I want to make it two block system, I must try to combine these two blocks first, correct? If I combine these two blocks, then upper block and these two blocks is like a single, then it looks like a two block system, right? Then it looks like the case which we have taken. I think this is the approach for three block. So this is no, first this is the thing is that how to combine the block, that is the idea here, because I can combine this, which one? So idea is that you combine this as a one block so that it looks like a two block system, right? Two block system. So now you do that only. Okay, you combine these two has become 20 plus 30, right? It has become 50 kg, correct? 50 kg, and the upper block is 10 kg, right? 10 kg. And this is how we have to think. Now it is like a two block system, right? So now acceleration of system will come same, because acceleration system calculations will give same 5 by 3. It doesn't matter whether you take this or that. So I assume that both of these are moving with the acceleration of this system as 5 by 3. This also acceleration as 5 by 3. Okay, acceleration will come same because the total force is 100 and total mass is same 60 Newton. So system acceleration calculation will come same. Now I think you need to do you need to do this first. You need to first check for this friction. Of course, this friction means here this friction we are talking, this friction F1. Okay, this friction we need to first calculate. So now do the free body diagram of this. Let us do the free body diagram of this. So upper block, which is upper block, which is 10 kg. On this 10 kg, this 100 Newton was acting, right? And it will, friction must oppose this relative to that. And lower block, which is a combination of these two. Remember, lower block is a combination of these two, which is 50 kg. Here friction must act like this one. Same friction F1, F1. Now you apply the same logic, step 2, and calculate. This friction first we need to calculate. So same acceleration system, so apply Newton's law. So let us apply here this F1 is mass into mass is 50 into acceleration of the system. Now you try 50 into 5 by 3, that become 250 by 3, correct? That 250 by 3 is giving us same 83.33, correct? This Newton. Okay. But what is the maximum value of F1? That also you calculate. F1 maximum value is how much? Maximum value. Mu1 into normal N1. So mu1 is 0.5 and normal N1 is 10, 100. So this is 50. 50 Newton. Don't worry, I think we are going correct. The thing which F2 will change. F2 calculation will change if we go by this approach. So we have got friction F1 is larger than this, right? But we are seeing that F1 is larger than F1 max, which is not possible. So we will choose F1 as how much? F1 as how much? 50 Newton, correct. We will choose F1 as 50 Newton. Now this diagram you consider F1 acting as 50 Newton. 50 Newton, and this is 50 Newton only, we have to take this F1. It cannot be that much. Okay. So now considering this, calculate the acceleration of this one. Upper one you calculate acceleration. Acceleration it will be 100 minus 50 divided by its mass, which is 10. Correct. So that will become 5, definitely 5 meters per second square. Right. Okay. So that means this is sliding, and what is the acceleration of this? Now the acceleration of this system will be different. This system means this 50 kg, which is made of 20 and 30 kg. That acceleration you calculate. Huh. Yeah, so that's why we will write this acceleration as this acceleration of 2 3. 2 3 means not relative, it's a 2 3 system. Okay, we are combining this 2 and 3, right? So that is acceleration of this system 2 3 to second and third block. Are you understanding? So so here the friction we have to take as F1 as 50 divided by this mass as 50. So this acceleration is 1 meter per second square. Correct? Yes. 2 3 system. 2 3 system. Now we'll go inside this 2 3 system and we'll see individual blocks now. So now this question has become a part of this lower two blocks. Lower two blocks is 20 kg and 30 kg, right? And we will assume that this acceleration of this is 1 meter per second square, and also we will assume that this acceleration is 1 meter per second square. Okay, and then we'll try to calculate the friction. So here already we have calculated this friction F1. So F2 must be acting like this way here, and this F2 must be acting like this way here. And now we will calculate F2, because F1 we have already calculated 50. F2 we do not know. Okay, so now you calculate this. Assume that they are moving together and now calculate Newton's law here or here, anywhere you can calculate. Let's take this F2. So this F2 is mass into acceleration. So 30 into 1, that is coming 30. But what is maximum value of F2? What is maximum value of F2? 0.25 into the normal. Normal means total weight. So 10 plus 30, 10 plus 20, 300, right? So how much it was? 75. 75 Newton. Now see, total means normal we are taking here, note. Here normal means above this. Above this means 10 and 20 both you have to take. Normal. Okay. Hmm. So that normal we have to take. So here see F2 maximum is 75 and F2 what you calculate is 30. So because this F2 is less than F2 max, then yes, it is possible. Whatever you assume it is correct. That means this is going with 1 and this is also going with 1. Done. This is the approach. This is the approach. Okay. So this is the uh, yes. Hmm. There now you understood the approach. Now we discovered the approach. That approach we have to books they will not give this. Books they will not give. You need to discover this because we have understood the approach for two block system only. So three blocks, four block, five block, you need to follow a particular approach. Now we got the particular approach. What is that particular approach? We have to, did you see how did we consider this one? I think you need to look at here. Yes, yes. So to convert into two block, you need to see where forces are applied. Forces are applied here, right? Forces is applied here. So below two, you have to combine as one. Previously, we were randomly combining them. Previously, we were combining these two, and then that is where problem was happening. Okay, so we need to combine this as one and these two as two. So we have to go from top to bottom. So first we have to calculate F1, find out what should we have to decide what is F1. Here F1 is coming as larger than that, so we have to take maximum F1. That's what we have taken, right, in this place, right? Because when we calculated F1, how much F1 came? F1 came as 81, 83.55, but maximum F1 was 50. So we have decided that this is not possible. So F1 we have to take maximum value 50. We decided this. Okay. Then we have gone to calculate this F2. So you have to go from top to bottom. That is the approach. Okay. Clear? But now see, suppose this force 100 Newton, if this 100 Newton was acting below, then how will you do? Suppose 100 Newton acts on the bottom block, then how will you do? Yes, yes, now you got it. That is the approach. now now middle means what to do then, huh? Hmm. Yeah, it's a good question if it is acting on the middle. Okay, first solve on this case. Okay, when it is acting at the bottom, let's try this case. Let us try this case when it is acting at the bottom. So 10 kg, 20 kg. Yeah, yeah, you can turn off. No problem. Okay, 20 kg. And you are applying 100 Newton here. So in this case, we will combine these two upper blocks as one. And then what will happen? This will become 30 kg. And this will become 30 kg. So we have applied force on the upper system as 100, sorry, lower force is applied on the lower one, 100 Newton. So this upper block will try to resist this, so it will apply friction like this way. This friction we are talking here, this friction we are talking up now. This time we are calculating F2 first. F2 we are calculating, same F2 will be acting on this here like this. Okay, so first of all, acceleration system you calculate. System acceleration will be same because total force is same and total mass is same, so it is going to be 5 by 3 on 5 by 3. Now assume that both of them move together with the system acceleration. Okay. So now let us do the calculation. uh, System acceleration already we know, so we study the free body diagram. So upper block, you see upper block, this is the only force which is acting forward, so this is mass into acceleration. Mass is 30 into acceleration of the system, so 30 into 5 by 3, so this becomes 50 newton. So this F2 is 50. What is maximum value of F2? That also you calculate. Maximum value of F2. Mu here, which is 0.25, 0.25 into the weight here. Weight means above this 20 plus 30, 300. So that becomes 75. Correct? 75 it is. So definitely this F2 is coming smaller than F2 max. So yes, it is allowed. Yes, it is allowed. That means F2 here is less than F2 max. So whatever F2 we have calculated, that only we have to take. That is what F2 we have to take, and we have to take acceleration like this. This means the lower block is moving. Lower block is acceleration A3. So A3 is same 5 by 3, and this here it's a system. It's a system of A12. Note that this is a A12 system because first and second we combine. So this we have to take as 5 by 3 only. Now we will go into the detail of A1 and 2. Okay. So let's go into the 1 and 2. So this is 10 kg and this is now 20 kg. And just now we have seen that here on this surface F2 is acting. This is what is F2. We have calculated that as 50 Newton. Okay, now we have to think of F1. So definitely here you have not applied force and it is moving that direction. So here friction F1 is acting like this and this friction F1. How are we deciding this F1 direction? Note that we are assuming that they are moving together. So definitely friction only is moving the upper block. So F1 is on the direction. Okay, and this F1 you calculate as mass into acceleration. So mass into this system 10 and 20 kg, this system is moving with this acceleration which is same as 5 by 3. So we'll use same as 5 by 3. So calculate this 50 by 3. 50 by 3 is how much? How much it is? 16 6 okay, this Newton. That is max. Now F1, now what is F1 maximum? That also you calculate. F1 maximum is mu. Yes. Because see here we have considered that they are moving together. We have assumed that they are moving together. So this upper is a system, not single block, but lower is a single block. Okay, so lower A3 is 5 by 3, but upper this 5 by 3 is for system, not individual block. Okay, that we have to calculate. That we will calculate individual. Now we are calculating A1 A2, will calculate. So what is F1 max? Here mu1 into normal one. So mu1 is 0.5 and normal is the upper block, that means 10 G, that means 100, that is 50 Newton. Okay. Now see here, this F1 is coming less than F1 max, right? F1 is coming less than F1 max, right? F1 is correct. That means yes, it is allowed. Whatever we thought it is correct, that means yes, this entire system is going, means each block is also going with the same acceleration. So A1 is also 5 by 3 and A2 is also 5 by 3. Here all the block are together moving. That is the answer for this question. Are you getting this? Then we will take middle block. That is interesting now. Middle block means it will, we have to think about. Let's try this. Okay. 10, 20 and 30. 30 kg. And we have applied force 100 Newton. Hmm. I think here only friction we have to think how frictions are acting. So both the blocks will try to resist, because suppose friction is not there, then when you apply this block, it will just go, it will just slide and both the blocks will combine, right? It will fall down, right? So that means both the blocks will try to, relative to both blocks, it is going away. So this friction will act here F1, and here F2 will be acting like this, and this F2 will be acting here like this, and this F1 will be acting like this. First we need to understand friction dialysis. Are you clear about this? See, you again assume that all the blocks are moving together, okay, together. So if all blocks move together, the upper blocks also move that side and lower blocks also move that side. So who can move them? The friction only can move them, right? Friction can only move them. So that's why friction F1, F2 is that direction, and because action and reaction on this, it will be opposite, right? That's what it is. Yes, friction F1 is accelerating, because when you are moving this, now if there is friction, this block will also get pulled that side. This get pulled that side because of friction offered due to that surface. Okay, that's what. No, no, no. I have given condition alone friction not accelerate means. See that condition we have given alone means, suppose if you will not apply any, but this friction is coming because you are applying here 100 Newton. Okay, suppose you don't apply, then this friction will not activate, right? If you don't apply this, then this friction will also not work. This friction is working because you have applied 100 Newton. Okay, so now let us try to how to approach this now. So can we calculate this F1? Which one should we calculate first? So can we take in this way also that all of them are going with the same system acceleration? Okay, let us take 5 by 3. All of them are going with same acceleration, system acceleration, system acceleration, system acceleration. All of them are going with same acceleration. So if I apply that idea, then we can calculate first here, because here F1 is acting and here only also F2 is acting. We can try this. Yeah, yeah, this also you can study. But you may say that calculating, that doesn't matter. You can take anyone, because we need to calculate both, because we have to compare with their maximum, right? We need to compare with that maximum. So F2 you first you calculate. Mass into acceleration, mass is 10 and acceleration is 5 by 3. So this becomes 50 by 3, 16.67 like that. Okay, right, 16.67 Newton. Okay, then should I use this F2 to calculate this F1, or should I calculate F1 directly? Now this can be a confusion. That can be a confusion. Should I? Because if you use F2 here to calculate F1, and here calculate, they may not be same. Let us try that. Let us try that. Suppose this is F, also first see what is F2 maximum, because we need to compare also. What is F2 maximum? Mu here is 0.5, normal is 100, so this is 50 Newton. Okay, so this is possible. We can accept this, right? We can accept that it is possible, because F2 is less than maximum friction. F2 is less than F2 max, so we can accept this. So possibility is that F2 is acting correctly. 16.67 is correct value. If I use this value, I can try to calculate whether this is going together or not. That also calculate. Let us try this. Newton's law on this. So 100 minus these two forces, F1 plus F2. 100 minus F1 plus F2, mass into acceleration. So into 20 into this. 20 into what? Mass into acceleration of system. So they are going together. So we have decided, right? So because this is going, it is less, so there is no relative sliding happening. So acceleration is system acceleration, which is 5 by 3. So if we do this calculation, what do we get from here? F1 already we have calculated. F2 you want. So calculate F2. This is 100. This will also come this side. 100 minus 100 by 3 and minus F1. F1 we have calculated, which is how much we have calculated? Um, sorry, F2 we have calculated. F1 we are calculating. No? We are calculating F1. F1 first you try to calculate because F2 we have already calculated. F1 you bring this in 100 minus this minus F2. Ah. No, these two forces are opposite. Now you are subtracting this. 100 minus these two forces, you are subtracting it. Net force you are calculating. Okay. Hmm. Yes, yes. 100 minus F1 minus F2. So do that. Do this calculation. F1 we want. F1 go this side. So 100 minus 100 by 3 minus F1 minus F2. F2 already we have calculated, which is 50 by 3. So let us keep 50 by 3 and calculate. So 3, this will become 300. 300 minus 150. 150 by 3. This will come as 50. 50 Newton. F1 is coming 15 Newton. So I have calculated that. And what is maximum? Maximum value of F1? That also you calculate. Mu here, mu is 0.5. Sorry, 25, right? 0.25. 25. And here total weight you have to take. So 30 you have to take. So that is 70. 300. So 75 Newton is maximum. So that 50 is coming less than 75. Okay. But my question is that first, if I try calculating F1 from here, then how much it comes? Let's also try. Newton's law here. This force is mass into acceleration. So 30 into system acceleration. So system acceleration is no, miss, we have to calculate separately first and check, because if you use this one and this one, maybe they can give different values of F1, because their F1, how much F1 has come? 50. Here let us check whether same is coming or not. And I think we are getting the same value. Correct? Same value, because this force is mass into acceleration, 30 into acceleration, 30 into 55 by 3. It is also coming 50, that is also coming 50. So yes, F1 cannot come different values. F1 calculation cannot give different values. If it is coming different, then we have to think further. But it is coming same value and maximum is 75 and it is less than 75. Yes, we can consider correct. That means here also all the blocks will move together with the same acceleration 5 by 3. Clear? But the problem will happen if sliding happens somewhere else. Suppose here some sliding happens, okay, and here sliding does not happen. Possibility is there. Possibility is there. Okay. In advance they may ask. For advance they can ask. Hmm. Yes, for advance they can ask. So I think here the middle, what you are saying, the middle, middle confusion is happening. Middle we can think it like that. When we are thinking the middle one, maybe we can combine the middle one and upper one as together. That is possible to do that. Middle and upper one together we can do, and we can, because if you don't combine, then you need to draw free body diagram of each one and then start it. That way also it will come, but some proper analysis you have to do, because there is no particular method of solving many block system. Two block system only, there is a particular approach. Three block we have to combine into two block to get a proper approach. Okay, so we have seen some mistakes can happen if we don't follow proper approach. Okay, so that's what it is. Any other question you have on two block system? That's also work out problems on this topic more and more. Then you'll get more experience, right? Okay, then we'll see, right? Yeah. That's what it will come. Maximum 3 4 question like this type is sufficient, right? Okay, fine then. Sunday probably it won't be there. Saturday also not there because Saturday I have other classes. So Saturday will not be there. But any doubts are there, you can send. Okay, that I can. Okay then. Bye. Yes. Good night.